Good morning, guys. We'll start the session. So to continue the last part on the IPv6, we will be looking at something like this, like say, for example, the last part, the transition technologies. That is the one of the important thing that again we will be going to discuss in here. Uh, it is something. Let me explain you that one. Right. So hope you can see the screen, right, guys? Hello.
Yes, sir, we can see the screen.
Okay, great, great. So now what we are going to discuss here is today like this is the concerns that we are having. I'll explain that in this manner. So we have uh, two different net. Let's say, for example, I'll get the practical scenario here. We have a this is the one of the practical example. We have a IPv6 running network. IPv6 running network in the sense IPv6 running network in the sense all those machines, the individual machines configured with the IPv6 addresses. Let's say, for example, 2042 DB8 colon 123/64 network. This is also, let's say, for example, 2042 DB8 124/64 network. This is also we can consider like 2042 DB8 125/64 network. Now, these are the individual machines. Just imagine the individual machines. So in here we have the uh, Skype server, Skype communication server, and here we have the Gmail service. Right? Skype server will run only on the IPv4 address. That means they are only capable of catering to the IPv4 request only. Gmail service where they have already running on the IPv4 and the IPv6 environment. What they have is they will be capable of dealing with the both V4 and the V6 environment. Let's say these computers are going to communicate with the Gmail service. Nothing to worry, since these are IPv6 and this is also they are supporting the IPv6 environment. They can easily communicate it because they know, okay, if the request coming from the IPv6, Gmail will respond through the IPv6 environment. If the request is coming through the IPv4, Gmail will request through the IPv4 environment. Nothing to worry. Let's just imagine here we have another machine which is running on the IPv4 address as well. Just imagine this is running on 202.1.32.20, like just a public IP that I have assigned here. So just imagine these servers are running on both IPv4 and the IPv6. This Gmail is supporting. Whenever the IPv6 servers are requesting the services from the Gmail, obviously they will going to give you the support, give you the services through the IPv6. Whenever the IPv4 machines, that is 202.132.20 machines, is going to access the Gmail service through the IPv4, nothing to worry, they are going to support from the IPv4. So that is done. This whoever the clients coming from this network, were able to access the Gmail service. It might be the IPv6 or IPv4, that doesn't matter, because they are going to, anyhow, they are going to get the service. But the issue is with this particular service provider, this is a real scenario we have faced at the time of 2012. I'm not quite sure whether the Skype is now supporting with the IPv6, because since this Skype has been bought by the Microsoft, now definitely it should support the IPv6 communication as well. But at the time that we were discussing, the Skype was with the Skype Incorporations, that is the parental company. Right now, the parental company for the Skype software is the Microsoft. Uh, I'm not quite sure whether that is already supporting or not, but at the 2012, 2013, there definitely doesn't support for the IPv6. This is a real uh, issue that we have faced while we are running the IPv6 environment on our network. So we have assigned the IPv6 to the individual PCs, actually, individual computers on 2013, right? The, Now look at this. Now we have the IPv6 v4 supported Skype server. Whenever the users are going to get the access, just give me a second, guys. Hello, guys. Hope you can hear me.
Yes, you
Right.
can.
So basically, if you look at this one now, the this 20240, whenever the IPv6 environment. So whenever the users which are running on the IPv6 try to communicate the Skype server, obviously they can't, because it's a two different protocol. It's something like whenever the two people meets, Chinese people and the Sri Lankan Chinese person and the Sri Lankan person, whenever the two people meet, they try to communicate each other by their own native language. It's something like this. Here also, we have a Sri Lankan people. Let's just say Skype service speaking with the Sri Lankan language, Sinhalese or Tamil. The this server, the computer is trying to communicate with the Chinese language. So whenever they try to talk with these things, or even it can be, let's say, if it is Indian, it's try to communicate with Hindi, right? Whenever they try to communicate with here in this particular environment in this manner, obviously they can't communicate because it's a two different language. They don't understand what they are saying. Because of that, if they use the body languages, body signs, obviously they can, up to some extent, they can, a certain level they can understand it, but obviously they can't understand anything. So that is the concern, that is the issue, because we are trying to communicate two different protocol in the same stack. That is not possible. So IPv6 will not be able to communicate with the IPv4. That is two different protocol. Guarantee that. IPv4 cannot be able to communicate with the IPv6 servers. That is also guaranteed. So since it's a two different protocol, so then how we are, this is one of the practical scenario where we have concern, we have actual issue, we have a problem actually. So how we are going to rectify or mitigate this type of issues, like, because there might be scenarios like the client will be running on the IPv6, only on the IPv6, whereas the service providers will be providing their services through the IPv4. This is the real problem, real issues that we will be facing while you are dealing with the IPv6 environment, while you are migrating your users to the IPv6 environment. The other way around also possible. The other way around, in the sense, the client will be using only the IPv4 environment, where the servers are running only on the IPv6, which is very rare, because obviously servers will not going to cater their services to the niche protocols, because IPv6, if you look at the total population around the globe, so out of this total population, only 1% is utilizing the IPv6 at the moment. So it is very rare case that the service providers will run their services onto the niche protocol, on top of the niche protocol like IPv6, but that is also possible. So anyway, we should consider about, whenever you are using two different IP version protocols, you have to consider how we are going to initiate the communication in between those two protocols. That is called, we required for this one, we required transition technologies. So there are different type of transition technologies that we will be utilizing, but the most common technology that we are using right now is the dual stack. This is the very famous communication transition technology what we are using. The rest of the transition technologies are considered as obsolete, because this dual stack is the much easier, much useful, much effective mechanisms that we are right now running dual stack. There is another transition technology called NAT624. I'll explain this one, DNS624. 624 transition. 624 transition. Or rather, in other words, we call it as a 624 transition. Then the other way is the 4 to 6 transition. 4 to 6 transitions. I'll explain is each and every these technologies, what we are actually referring to this one. What we actually means by these technologies, right? We'll start with the easiest one and effective one, and the most common transition technology what we are using is the dual stack. I'll elaborate with the example. Dual stack in the sense, nothing much. If you have seen this one, the single adapter, look at this one. This is my existing wireless communication right now. The single adapter will be capable or will be supporting for configuring both IPv4 and the IPv6 address. The single adapter, this is my wireless adapter. Wireless adapter will be able to provide the both IPv4 and the IPv6 configurations. In my case, if I show you, you can't see this one, right? Can you see this one, guys, now? So this is my existing wireless communications. You can see that is connected. So this contain two things. It support for both IPv4 and the v6 configurations. If I show you this one right now, look at this configuration. This is my adapter configurations. Here I have configured both IPv4 configurations. Look at this. This is the IPv4 configurations. This is the IPv6 configurations. You can see that one. IPv4 and the IPv6. a single adapter have been configured with the both communications. What is going to be happen here is, so it is something like this. So we have a servers, we have a client, let's just say these are the client environment. Let's just say these are the client environment. Which is running on the 240, let's say what is my IP address, 2407, this is. Right. Now, if the server, like say for example, ping www.google.com, let's say for example, I'm just taking this example, okay. Now you can see the IPv6 address. So I'll try to get the IPv4 address of the Google. Now you can see that is supporting for both. Look at this, that is supporting for both. Right, right. So now, whenever these clients are trying to communicate, with this IPv6 address environment, with this environment, since my adapter has been configured with the both IPv4 and the IPv6, the by default priority, this is keep in mind that by default priority, that is the default mechanisms, default way that they are going to use it. By default priority is going to the IPv6 environment. Are you clear, guys? Do you have any issues, concerns so far what we have discussed? Are you clear,
No, sir.
guys? Huh?
No, sir.
Okay.
Explain again.
Yeah, sure, sure. Sorry, guys. Right. This is again I'm going to discuss here. whenever you are going to deal with, just imagine whenever you are going to deal with, can you tell me what is exactly not clear? Is it a dual stack mechanism or what I have told you that the priorities? ඔයාලට තේරෙන්නේ නැත්තේ මොකක්ද exactly?
ඩුවල් ස්ටක් මෙතඩ් එකේ එතන අන්තිමට කියනවගේ සර් තේරුම්
අන්තිමට එක කියන්නේ මොන ටිකද කියන්නේ
අද
වෙන්නේ?
ඔය ප්ලෑන් එන්වයරන්මන්ට් එකයි ඊට පස්සේ අතර මේ අනිත් එන්වයරන්මන්ට් එක ඇතුළේ තියෙන අන්න එතන පොඩ්ඩක් පැහැදිලි වුණේ නෑ සර්.
Right. Okay. I'll explain that. So whenever you are going to deal with IPv4 v6 communications, whenever you are going to deal with the IPv4 v6 communications, it is possible to configure, this is again I'm telling that, it is possible to configure the both IPv4 and the IPv6 addresses on a single adapter. That is what we call it as a dual stack. This is what you can see here. My wireless adapter has been configured with the IPv4 as well as the IPv6. These actually I didn't configure it. These are automatically taken because if you can see here, particular adapter has the IPv4, it's set to the automatic, IPv6 also set to the automatic. That's why these two IP addresses are assigned. This is actually assigned by the router. This is actually assigned by the ISP, right? This is Mobitel environment. You can see the Mobitel ISP, right? Mobitel, this is 4G communication. So which is you are going to get. Now, just imagine, like, look at this. 192.168.104.20.2407 C00 D005 4EEE ABED 425 160F 4882/64. This is what exactly we call it as a global IPv6 addresses. Now, actually, I do have the routable IPv6 address assigned to my computer by the ISP, right? Since this is a home network, I can't have the IPv6 addresses other than that. So this is a public routable IPv6 address assigned to me. Is it clear, guys?
Yes sir.
What about the others?
Yes, sir.
So what about the Hasita, Deepika? What about you guys? Okay. Right. Hope you are clear with that. So the dual stack method, I think you have cleared, right? So it simply says you can configure the IPv4 and the v6 address, both IP addresses in a single interface. That is what exactly simply says. Right? Right. Now, just think about, we have a two clients which are running on the IPv6 environment. Here, this is the IPv6 address, this is IPv4, this is the IPv6 address, and this is the IPv4. The Google server, this is the Google server actually, what we will be looking at. The Google server will have also configured with the both IPv4 and the v6 environment. This is the IPv4 address of the real IPv6 address and the real IPv4 address of the Google. Real things, right? Now, this is the, keep in mind, this is the default behavior. Whenever this particular client is trying to access the www.google.lk, www.google.lk. Just give me a second, guys. Sorry, guys. So there's one questions asked from here, like එහෙම හදන්නේ නැහැ. ඒ කියන්නේ IPv6 විතරක් support කරන adapters කවදාත් හදන්නේ නැහැ. අනිවාර්යෙන්ම whatever the network adapters that you are going to use in future, that is going to be the dual stack supported. That means the network adapter will be able to configure both IPv4 and the IPv6. If they have created like adapters, just in hypothetical scenario, just imagine there is an adapter that is only supporting IPv6. Obviously you can't access the IPv4 supported websites. That is guaranteed. Only IPv4 running websites, that is guaranteed. Is it clear, guys? Right. So now just imagine, just look at here. Whenever you are going to deal with this environment, look at this client environment here. Now, this is the default behavior. If I'm trying to, let's say for example, this is client A trying to access google.lk. Since this client and the server both are configured with the dual stack environment, that means both IPv4 and the v6, the default behavior on the network stack, they are going to give the priority to the IPv6. That means by default, the communications will be going through IPv6, not the IPv4. Is it clear now, guys? So this is the right now, if you're going to configure the IPv6 addresses, IPv4 network, IPv6 network in your environment, this is the current technology that we actually really using today's. Just give me a second, guys, again. Right, sorry, guys. So yes, right, guys, do you have any problems, any concerns? Anything to ask in this related to this one? Guys?
Sir?
Yes,
Okay.
you're fine, right? Right, okay. So now let's look at this is the way that they are going to use it. Like the dual stack, that is guaranteed. We don't have any type of other type of transit. We don't use actually other type of transition technologies, because this is easy and straightforward. Just put it even if you look at, because I just took example uh, with the IPv6 onto the client environment. But if you look at the even, because it does not support, even though we did configured only to the IPv6 to the client or the servers, that is simply there for the endpoints computers. That doesn't make any sense, because if you want to really get the utilization of the IPv6, all the network devices also has to be configured. Otherwise, we can't do the communications, because from this point onwards, we do dealing with the different type of switches, routers. Switches, of course, they don't want to worry about what the IPv4 address, because they don't consider about the network layer. They are only dealing with the simply the what we call it as the they will be only dealing with the IPv. They simply dealing with the IP, not the IP addresses, but with the MAC addresses. But really, what you really look at here is the rest of the things, like the routers, layer 3 switches. That is when the devices which are dealing with the rest the others will be very much important. Others will be very much important. That is simply they are going to need to support the IPv6 as well. All the network devices today is what we are right now running, not earlier versions. If you look at the earlier versions, they don't support the dual stack because we don't have the tab called IPv6 tab on there. So all the IPv6 earlier, the devices, today's devices are supporting the dual stack mechanisms. So that means simply you can configure the IPv4 and the IPv6, uh, IPv4 and the IPv6 uh, onto the all the devices, network, servers, anything. So that is what we are really looking at. So even in the middle of these communications, so this IPv4 and the IPv6 is supported. Are you clear, guys? Guys, do you have any issues, concerns? Okay, great, great. Hope you all are fine, right? Right. Okay, guys. So hope you are clear with this. So that now it's actually easy, but this is what I want to highlight here is whenever we are going to deploy in 2012, this dual stack mechanism was not implemented at that stage. Actually, that was implemented, but we didn't use that one in pretty much confident manner. Uh, what we have used on that area is I'll explain that concepts also. That concept also. Right. So now let's look at this one. This is what I want to give you in the client environment. In the client environment, let's say for example, this is the client machine and this is the server. Server machine, two things. Now the client will run on the IPv6 environment. Just imagine, let's take this example again. They are running only on the IPv6. They are running only on the IPv6. Whereas the server, like Skype server, will supporting. Let's try to get the let's try to get the. I'll try to ping and try to get the. Yeah, it is supporting only for the IPv4. Skype server does not yet support the IPv6 because when I try to ping it, So it will try to resolve the IPv6 IPv4 address, not the IPv6. So it is still pinging, right, for the IPv4. So now, whenever we try to communicate, obviously this communication does not happen. Communicating V6 with the V4. Skype will not work definitely because we do have two different protocols. Whenever you require to deal with this IPv6, IPv6 V4 environment, V6 V4 environment, what we are going to do is, this is exactly we will be going to deploy. We are going to deploy in the client side. In the client side, we are going to deploy the server called NAT624 DNS624 server. There is a separate image right now. That is image won't be available in the internet. Previously, there is a separate Debian image called NAT624 DNS64 server. It's a different image actually. Now you don't get that one because since we are not using this one, they have actually removed it. Simply they removed that because of we it is no point of using it, because it's no point of using it. So but what we are going to do is we are going to deploy the DNS server which is having the NAT624 and the DNS64 in this particular environment. In here we are going to put we have the two IP two network card. One will be configured with the IPv6 address, the other one will be configured with the IPv4. Whenever the client requests the communications, basically the gateway for this particular client machine will be this server. The gateway for the client machine will be this 64 DNS64. So all the requests will be going to the first of all the request before they are going out. Since this is the gateways for this one is this NAC64 DNS64, the IPv6 communications will directly hit to this particular server. This server will first try to negotiate with the endpoint or the server environment, the service provider, and try to look at whether they are going to use the IPv6 or v4. If the server is, let's say for example, the client is trying to communicate with the Google machine, that is the Google.lk as well. Since the Google is supporting the IPv6, they don't do any changes. The communication will be going through the IPv6 environment, will be going to go to the Google server and get the response back to the NAT64 DNS64 server and reply to the client machine. That is exactly what they are going to do. But whenever they try to access the server which are only supporting IPv4 communications, the VP6 communications will be terminated in here, and that particular communications will be translated to the V4 communications and send it to the V4 server. So now the V4 request is coming down here, and the V4 request will be replied back. The Skype server will be replied back to this particular NAC64 DNS64 machine, and reverse mapping will be going to go again because the netting has been reversed to the that V4 address will be again mapped to the V6 and going back to the V6 communications as usual to here. That is, we call it as a DNS64 NAT64. Are you clear, guys? Are you clear this particular environment? This is a special server that we are going to deploy on the client premises if you want to start the communications with the IPv4 environment, if your client are running on the IPv6 environment. Guys, are you clear with this?
Clear, sir.
Do you have any issues, concerns so far what we have discussed?
සර්වර් එක කොහෙද තියෙන්නේ? ISP ගාවද කොහෙද සර්?
මොන සර්වර් එකද?
net 64 DNS
නෑ 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 ඒක අපි දාන්න ඕනේ. ISP එක තමයි මම කිව්වේ client පැත්ත දාන්න ඕනේ. මොකද client නේ වැඩි වැදගත් වෙන්නේ. ISP දාන්න ඕනේ නෑ ඒක. ISP ට අදාළව නෑ. client නම් IPv6 IPv6 environment එක run කරන client තමයි දාන්න ඕනේ. Clear the guys?
yes sir.
අනිත් අයට මොකද ප්‍රශ්නේ? ප්‍රශ්න තියෙද ප්‍රශ්න? Do you have any issues, concerns? Please respond guys. Rest of the things, there were about 40 people in the session, so but I'm receiving the feedbacks only 2 to 3 people, so I need your feedback guys, whether you have cleared or not. Okay, so that means we are good to go, right guys? Right. So the other way is the reverse thing. So 6 to 4, this is actually this 4 to 6 transition is very rare that we are going to use. The reason I'll explain you, but dual stack is the most common method that we will be using today whenever you need to deal with the both v4 and the v6 environment. If you want to access the both v4 services and the v6 services, NAT64 and the DNS64, it was earlier, it was very much popular, but nowadays actually we will be not pretty much utilizing it because it was really not required to use it. It was not really required to use it because since we do have a more efficient and easier to configure mechanisms called dual stack. Because if you go with the 6 to 4 communications, for the dual stack communication, 6 to 4 transitions, you need to deploy a separate server on your client premises, on your environment, which is again an overhead for us, a burden for us. So we don't do that one because without dealing with any other servers, we can straight away deal with the dual stack. Because operating system itself and the other network devices also itself, they are supporting this dual stack mechanisms. So we don't want to deploy any servers at the time that we were talking the IPv6 transition technologies. Because I do have experience with both dual stack and the NAT64 DNS64 mechanisms where we don't use the 4 to 6 transition, since I don't have any experience with the 4 to 6 transitions as well, but I'll explain the concept. Right. That is going to be definitely the other way around. Let's just imagine something like this. Just imagine we have a client machine which is running on the IPv4 environment. Right. Now we have another server environment, which is, let's say, for example, Skype, which is running on the IP, only on the IPv4 environment again. Another server, we have another server. Let's say I have hosted the website, let's say, for example, Univotech website. Just imagine. They are only running on the IPv6 where they didn't configure the IPv4. But that's why I told you this is very rare. The reason is service providers does not try to run their services on the niche protocols. These are because out of the whole global environment, it's running only 1%. So this is a niche protocol. So niche environment. That's why I told you this is very rare to run the IPv6 environment. Very rare to run the IPv6 environment only on the service provider side, because otherwise they will definitely run the IPv4, or else they are going to run the both. That's it. Not only the IPv6, but if you just imagine, if your website is running on the IPv6, whenever you really require to access the IPv6 supported services, you need to deploy again on the client side, this 4 to 6 transition server. What they are going to do, it's the same thing again. We will be having two network adapters which are supporting both IPv4 and the v6. Here we have the IPv4 communications, and we have the IPv6 adapter also here. The same thing what is does is like the NAT64, the NS64, what they are going to do is they will be going to, whether they are going to look at, okay, just give me a second, guys. Just give me a second. Right. So now look at this one. Now we do have the 6 to 4 definitions here, 6 to 4 definition here. So if you try to access IPv4 communications, nothing to worry. As normal, as stated, they are going to access the Skype server through the IPv4 communication. For this particular client machine, this server will be the gateway. If they try to access IPv6 communications, then translation will be happen here, and the IPv6 communications will be going to go there. The reverse will be getting the gain, and retranslations will be occurred within the server, and the communication will happen. So this is called 4 to 6 transition, where very rare that you are going to use it. Actually, you don't want to use right now, because we do have the most common method that is called dual stack. So we don't want to use the 6 to 4 transition mechanisms or the 4 to 6 transition mechanisms separately, because that is obsolete technologies that we are right now using. Is it clear, guys? Are you clear? Guys, are you clear?
Yes, sir.
What about the others?
Okay, sir.
Okay. So this is actually what I want to highlight here in the last, as the last part on here, like the transition technologies uh, in the IPv6 environment. So this actually conclude your IPv6 concepts. IPv6 concepts, the basic introductions, and the we have dealing with the UI64 methods and so forth. So the only thing that we didn't cover in the IPv6 here is the subnetting part, but other than that, all the other required content we have covered. So IPv6 subnetting is very much similar to the, it's not a big deal to deal with it like the classless or classful or we don't have that type of concept. It's just a straightforward the subnetting concepts that we are using. Straightforward communications. Right. So hope you are clear with this, which we have discussed about the IPv4, V6, all the communication protocols. Next, what we are going to start is the routing protocols that we will be going to introduce the routing concepts and different type of routing protocols that we are using, and what are the important aspects on the routing environment. So this is what we will be going to learn as the last part of your course, which will be once we complete that one, which is we are going to wind up your whole lecture series for your semester. Most probably we will be able to wind up the routing and everything. So because today we will be going to start the basics on the routing, and we will be able to cover the rest on the next week. So next week, that means before the January 1st, before the Jan 1st, we will be wind up your lectures. So nothing to worry about it. Right. So we'll have a short break, guys, like 11:50 right now. So we'll meet on 12 exactly, and we'll start the routing concepts. Okay, guys. These are all the things we call this as routers. So whenever you are going to whenever you are going to send the data packet, let's say for example you are going to access www.google.lk, that you are going to access the website www.google.lk. Obviously for this machine, this is the gateway router, this is the gateway. So they will look at whether this particular domain name, whether this particular IP address are in your environment. If it is really not your environment, uh, obviously they are not going to use it. They are not going to use it because they are going to send the data packet to the router if it is not really intended to their environment. If it is not in their environment, they are going to send the data packet to the gateway. So the router will receive the gateway, and this particular router will receive the gateway here. So the www.google.lk, and to this particular router, and router next is need to decide, okay, if they want to send the data packet to the google.lk, first thing, what is the next hop, what is the next point that they need to pass the data packet to next router, what is the next hop, and then second thing is next hop, and then what is the suited best suitable path, what is the nearest path. So these two has to be decided before they are going to send the data packet to the intended recipient. intended recipient. This is exactly what they are going to do. This is exactly what they are going to do. Are you clear, guys? Right, guys. Sorry for the since actually working there, I'm getting so many calls. That's right. Right. So anyway, so this is the idea of the router. Like they need to decide the simply they need to decide what we call it as what is the next hop. That means where to send the data packet and what is the best routing path. So these are the things that they must decide. So I'll explain by taking a layman example. Just think about like what we are going to do here is I am going to let's say for example I'm going to go for a trip like from here to, let's say for example where we are going to go. uh, let's imagine that we are planning to go for a trip by targeting this long holidays. Let's say for example we'll be targeting for the Baticolor site. Let's just imagine we are targeting to go for a Baticolor site, right? So whenever we will be targeted, that whenever we have planned the trip, so the next thing that we need to look at is the route. So the next hop in the sense from the starting point. Let's say I'm going to start from my home. That is, I will be living in Piliandala. So I be starting from Piliandala. So once I decided the path, like let's say for example, because if you look at to reach to the particular, so we do have so many ways from the Piliandala. We can start the particular path from the different ways. Like we can just go to the next stop will be go to the Kahatudu highway entrance. From the Kahatudu highway entrance, I will be exit from the next stop will be the Kadawat entrance. From the Kadawat exit, that I will be taking the Candy Road. So from the Candy Road, that is the next stop will be the next turning point will be where that is Alaua. So the Alaua will be the turning Alaua, no, sorry, Abepusa. Abepusa will be the turning point. So from that particular turning point, we can take the route to the Kurunagala, and from the Kurunagala, we can take the next stop to the Dambulla. From the Dambulla, we can take the next stop to the let's say for example රින්කෝ යන පාරවෙන් රින්කෝයි පොළොන්නරුවේ වෙන් වෙන්නේ කොතෙන්දද? Habarana. So we can go to the Habarana. From the Habarana, we can take the right turn and then go straight away to the Polonnaru. Polonnaru then Manampitiya, and then whatever the roads that we will be going through, like Manampitiya. Then what are the roads, the towns that we are passing from the Manampitiya to Vaticolo? Do you know any? Because I can't remember those towns actually. So if you can remember that, you can tell it. But anyway, those are the next stops, next points that we are going to use. Next points, right? So from that we can take the again from the 1 points we have to again take a right diversions, and that will be goes directly to the Batigolo city. If I'm not mistaken, that is the route. So that is one way of going there. The next part that we can take it here is we can rather than taking a turn on the Abepussa, we can directly straight away goes to the next stop will be the Candy City. From the Candy City, the next stop will be the next things will be like Candy Mahiyangana Road. So Hasalaka Mahiyangana, then again Dehiyatta Kandiya, Dimulagala. So likewise, we can go from there and Dimulagal, and then again we will take again from the Manampitiya, we will take another right turn, and then again straight away goes like that is the Baticular road, the Polonar Baticular road. So we will be going to the Baticular as we stated. So likewise, we will be having a different path, different routes to reach the Baticular from the Pilianda. If you, let's just imagine, if you are going to go by uh, your own vehicle, obviously you don't think about the distance, but let's say for example you hired, just again excuse me guys. Right, from that particular points onward, so you now can understand how we are passing the towns. Those are the town will be act as routers. We decide the next stop, next town, next town, next town, because whenever we change the next town, whenever we change the next town, so the routing path or the distance and the path will be differ. Is it clear, guys? Do you have any issues, concerns so far? Do you clear? Do you have any issues, concerns so far? Right, okay. Great. Great. So now let's move ahead in this manner. So if you are going, like I told you, that if you are going with your own private vehicle, you don't consider about the distance. What you are considering here is you consider about the, like, the enjoyment of the trip, right? The that doesn't make any sense how far you go, but at the end of the day, if you can try to able, if you are able to reach to the particular the destination, that will be fine. But when it comes to the routing, the cost does matter. When you are going to deal with the when you are going to deal with the this particular environment, definitely cost is the main factor that we will be going to look at. Cost is the main factor that we will be going to look at in this environment, in the router concepts. So with the very let's say for example with less cost effective manner, with the very less cost effective manner, they are going to deal with it. So very few concerns that they need to look at here is the total the data packet traversing concepts has to be 100% cost effective, cost effective. So that is the whole idea on this environment, right? Now, in order to enable, because obviously whenever they need to decide the cost effectiveness, they should require a sort of a mechanisms, these routers, because routers are the path tellers. They are the people who's going to tell you the path. I told you that, always remember, in the beginning of the lectures also I told you that routers are the path tellers. They are the people who tell you whenever you want to reach to the next destinations, what is the best path, what is the cost effective path to reach there. Best and the cost effective path. Because when you say best, it does not make even that is, they don't consider about the only the cost. So when you say best, it is just say the cost effective sense seems to be the best, and in terms of cost as well, and the best in the sense the efficient. So they will look at the efficiency also. So that is what exactly they will be looking at whenever they are going to do, in order to decide those factors. Because whenever you send the data packet to the router, in order to decide okay, what is the next stop, what is the best part, if you we have decided the next stop, what is the best part to send the data packet to the google.lk. Whenever you are getting the reply also, the routers also do the same calculations. They must decide what is the best path, what is the easiest way to reach it. In order to decide that one, in order to decide that one, they use different type of algorithm. That is, we call it as a routing algorithm routing algorithm to decide it. So what are the routing algorithms they are using? They were having different type of routing algorithms. They were having different type of routing algorithms that they are going to use it. Can anyone tell me what are those routing algorithms that they are going to use?
Adaptive, non-adaptive.
Can anyone tell me what are these things? What was the routing protocols, algorithms that we can use? Routing actually not the algorithms, it's protocols. What are the routing protocols which used to define your path and your next stop? What is your best routing environment, best route path?
Open sorted pass.
Okay. So there are different type of routing algorithms that we are going to use. One is RIP. What is the RIP mean? What is that? Rest in peace. Right, guys? We have a RIP, rest in peace. RIP also we do have two different algorithms, version 1 and the version 2. Guys?
Okay, sir.
Okay. What is then the RIP stand for?
Rest in peace.
Right,
Routing
okay.
Information Protocol.
Yeah, exactly. Okay, so the RIP stand for not actually the rest in peace. It's called actually a routing information protocol. Routing information protocol. So we do have routing RIP versions 1 and the version 2. There are two versions that we will be using, RIP version 1 and 2, routing information protocols. Then again, we do have another type of protocol called OSPF. Can anyone tell me what is the meaning of the OSPF?
Open Shortest Path First.
Yeah, so it says open shortest path first. So that is what exactly we are going to do. So we have the OSPF, open shortest path first, and the rest in peace. Not the rest is RIP versions 1 and the 2, routing information protocol. Then again, we have another proprietary protocol called EIGRP. This is the Cisco proprietary protocol where if you want to use the EIGRP, you should have the Cisco environment only. This routing protocol is a totally Cisco proprietary protocol. Can anyone tell me what is the EIGRP stand for? So it says
Enhanced Interior
enhanced
Gateway.
Yeah,
Interior Gateway Routing Protocol.
enhanced sorry, enhanced interior routing interior gateway routing protocol. Gateway routing protocol. So previously they have used the IGRP. This is the enhanced version. EIGRP is an enhanced version of the IGRP. So, but anyway, you just keep in mind this is a proprietary protocol which is used in the Cisco environment. Then again, we do have another two protocol, BGP, IBGP, and the EBGP. Can anyone tell me what is the IBGP and what is the EBGP? What just tell me what is the BGP?
Border Gateway Protocol.
Exactly, border
And actually internal border
gateway protocol.
external border gateway protocol.
So IBGP in the sense internal border gateway protocol, internal border gateway protocol. EBGP in the sense external border gateway protocol. So if I give you the simple examples here, like what is this IBGP and the BGP, we are going to discuss not we will be not going to do some demos in here, like because since this is a introductions, that is computer network introductions chapters, like a course on the first year, we will not going to do any demos. That's obviously it's going to be the 100% theoretical environment. So we are going to discuss the basics idea of the EBGP, IBGP, and the BGP protocol, and they can IGRP, EGRP, actually EIGRP, then Ospf version 1 and the version 2. But you need to remember that whenever you are going forward, the version 1 and the version 2, these two protocols are actually rest in peace right now. So they are actually no longer using in our live environment, because these are not really a good thing, like a good solid protocol to use today's network. But if you want to deal with the whenever you are using it, if you are going to deal with your environment, you most probably using um, let's say for example OSPF, EIGRP also very, it's a pretty much popular one, EIGRP, for your routing environment, for your routing environment. You don't get the experience with the most probably BGP unless you are work with the Lankacom or Sri Lanka Telecom, because BGP most not even the Lankacom or Sri Lanka Telecom, BGP will be used most probably as the ISP service providers, internet service providers. The BGP is used by the ISPs. So I'll explain the BGP concepts and why we are going to use the BGP when we are dealing with this one. Just give me a second, guys. Sorry, guys. So so this is what really require, like we did use different type of uh, concepts, like the routing protocols to deal with this routing environment. Apart from that, it is really required to know that this is actually we actually call it as this type of, if you use this type of algorithm to define or design the routing, these are, we call it as a dynamic routings. But when it comes to deal with the if you want to deal with the you are, let's say for example, you don't want to use the dynamic routing, then obviously like it is just only used in the internal purposes. Of course you can deal with, rather than dynamic routing, you can use the static routing. I'll going to explain this one also, static routing concepts. Static routing in the sense we are going to manually add, we will be adding those things. Dynamic routing, it's going to be automated process, where once you configure the routing protocol in with the necessary parameters, it'll automatically get the routing entry details on the internet. So because it is not possible to let's say for example, when you dealing with the internet environment, it is definitely not possible to have it to have the static route. So where they will be going to use the dynamic routing entries. So that is the main purpose that we are going to use. Are you clear, guys? Are you clear?
Yes, sir.
Do you have any issues, concerns so far what we have discussed? So we will be going to look at those two things, like static routing and the dynamic routing, and how we are going to add those routing entries. So just to give you idea, but really we are not going to deal with the practical environment there. If you want to experience those things, you can use the packet tracer. There is a tool called packet tracer, and you can utilize that one. Okay, guys.
Okay, sir.
Yes.
Right, great. So with this, we are going to wind up the lecture for today. So next week we will be going to cover out the routing concepts. That is going to be the last lecture most probably. So we'll be going to deal with the next week somewhere on I guess somewhere on Thursday. That will be good. 31st, that we can cover the, the lectures on the next week, and we'll be going to able to deal with the actually we will be going to able to conclude your the course for this particular semester 2. Right, so we'll meet on next week then, guys. Until that, have a safe week, and Merry Christmas those who are celebrating the Christmas, and definitely before the new year we are going to meet. So for the rest, those who are actually celebrating the Christmas, Merry Christmas, guys. Stay safe, and hope you are having a great Christmas. Not actually great Christmas, but at least try to celebrate that one.
Okay, sir. Thank you very much.
Okay.
Thank
Okay.
you, sir.
Thank you, sir.
Okay.
Christmas
Bye,
and
guys.
happy holidays.